Good morning, students. Today we are going to read diffusion in chemistry. This is very important topic. So concentrate yourself. The definition of the diffusion is the random movement of particles from a region of high concentration to a region of lower concentration. Diffusion can takes place in gases, liquids, and solids. Diffusion is fastest in gases because the gas particles are very energetic and move with great speeds. Diffusion is slower in liquids but still much faster than the solids. The particles in the liquid and solid move much more slowly than those in gases. The speed of the diffusion is affected by. So there are two factors which affect the speed of the diffusion. Number one is temperature. And number two is molecular mass of the particles. So now we are going to discuss the factors. The first factor which affects the diffusion is temperature. The higher the temperature, the faster the diffusion. At high temperature, the particles are more energetic. That is, they have higher kinetic energies and hence move with greater speeds. The second factor that affects the diffusion is molecular mass. Lighter particles have smaller molecular mass, while heavier particles have larger molecular mass. At a given temperature, particles with smaller molecular mass diffuse faster than particles with larger molecular mass. Because lighter particles can move more fastly as compared to heavier particles. Now, we are going to read the experimental evidence. Formation of the white fumes of ammonium chloride. The procedure is: a piece of the cotton wool is soaked in concentrated hydrochloric acid. The acid gives off hydrogen chloride gas. So here is a cotton wool that is soaked into hydrochloric acid. This acid will give off the hydrogen chloride gas. Another piece of the cotton wool is soaked in concentrated ammonium solution. The solution gives off ammonia gas. Put both pieces of the cotton wool at opposite ends of a dry 100 centimeter long glass tube as shown below. So this is the setup. Observation: a white ring is formed after about 5 minutes. The white ring is located closer to hydrochloric acid end of the tube. Explanation is: ammonia particles are lighter than hydrogen chloride particles. Ammonia particles diffuse faster than hydrogen chloride particles. Ammonia particles traveled further than hydrogen chloride particles. The white ring is formed by solid ammonium chloride. And here is the equation: ammonia plus hydrogen chloride forms ammonium chloride. Another example is: which of the following would diffuse more rapidly? Chlorine, carbon dioxide, methane, nitrogen gas. So CH4, it has the smallest relative molecular mass. You student will find the molecular mass of all these four substances, and out of these four you will find out that CH4 has the smallest relative molecular mass. That's why it will diffuse more faster. Another example is a beaker of the nitrogen was inverted over porous pot containing carbon monoxide as shown. The water level did not change. So here is a beaker containing nitrogen. Carbon monoxide gas is here, and this is a porous pot. Water level keep its level. So the requirement is the reason. Reason is nitrogen and carbon monoxide have the same density. Because they have the same relative molecular mass of 28. Therefore, their rates of diffusion are the same. The number of the molecules that remain in the pot are the same, resulting in no change in the pressure, hence no change in the water level. Another example is figure below shows the apparatus used to study the diffusion of a number of the gases at the same temperature and pressure. And gases will be ammonia, carbon monoxide, hydrogen, nitrogen, and sulfur dioxide. Here is a porous barrier, here is vacuum, and here gas will be placed. A part's requirement is calculate the molar mass of each of the above gases. So first ammonia, here is the molecular mass. Then carbon monoxide, then hydrogen, nitrogen, and sulfur dioxide. So these are the molecular masses. B part is what factors affect the speed of the diffusion? So the answer is temperature and molecular mass of the particles. C part, which gas would diffuse into the vacuum at the slowest rate? So the answer is the sulfur dioxide, because it has the highest molecular mass. We can see from here 64 is the highest, that is the mass of the sulfur dioxide. So that's why it will diffuse more slowly. And D part is identify two gases that would diffuse into the vacuum at the same speed. So from here we can see the molecular mass of carbon monoxide and nitrogen gas is the same, that is 28. So nitrogen and carbon monoxide, because both have the same molecular mass, so that's why they will diffuse at the same rate. Next topic in the lecture is applications of the diffusion. First application is detection of the fragrance from an open bottle of the perfume or aromatherapy solutions. Second application is aroma of the food from the kitchen. Next application is undesirable odor from a garbage chute. And other application is color of the dye spread uniformly throughout the solvent. And other application may be particles of the coffee granules or Milo powder spread evenly throughout water after being mixed. Next, we are going to read the explanation for the spread of the perfumes and cooking aromas. The fragrant particles from the perfumes or cooking aromas escape into the air. These particles then diffuse out in all the directions to reach our senses. Explanation for the spread of the coffee and tea grains in water. The water molecules are in constant random motion. Water molecules are constantly bombarding the tea or coffee grains from all directions. Because of the unequal bombardment from the different directions, the grains are pushed haphazardly about throughout the water. Here is an example. Air enclosed in a porous pot connected to YouTube is placed in a beaker containing carbon dioxide. So here is the apparatus. The levels of the colored liquid in the YouTube changes from A to B. As shown in the figure below, explain the changes. So the level of the colored liquid in the YouTube is changed. So requirement is explain the changes. So air enclosed in the porous pot connected to YouTube, air is closed. Here is a porous pot in a beaker containing carbon dioxide. So carbon dioxide particles are heavier than air particles. Carbon dioxide particles diffuse more slowly as compared to air particles. Air particles diffuse out of the porous pot faster than carbon dioxide particles diffusing into the porous pot. So air particles will diffuse more fastly to carbon dioxide, but carbon dioxide being heavier than the air will diffuse slowly to the air. Gas pressure inside the porous pot drops, creating a partial vacuum. So here we'll create a partial vacuum. The higher external atmospheric pressure pushed the liquid level in the right arm of the YouTube downward. So this will push downward because here is creating a vacuum. So this is the reason for the change. Another example is an experiment was set up as shown below. After being left standing for several days, the liquid in the gas jar had the same orange color throughout. Using kinetic theory, explain the changes. Here is distilled water, here is aqueous potassium dichromate. Aqueous potassium dichromate consists of orange particles. Water consists of colorless particles. The orange dichromate particles move out randomly in all directions and mix uniformly with the colorless water particles to form a uniform orange color. So this is the explanation. So this was the topic. Read it again very carefully and make your notes. Thank you so much.